Hi, welcome to the Mentored Engineer. In this episode, we are going to look at our log splitter and how there's a couple areas of structural concern that I have that aren't really covered by calculations, but if you're designing something, you probably just want to make a few changes. All right, so here's the first one. We've got this bar on the back of our log splitter, and it goes right here, and it attaches there, and here, and then it continues up to the top. The problem with this is it just doesn't do anything. All right, so it might add a slight bit of structural strength to it if you're working over the front of the machine, but as soon as you rotate to the side, it offers nothing. It's on the neutral axis at that point. All right, so get rid of it. There's no purpose in it. The designer probably looked at it and said, yeah, that'll work. All right, so the second thing we have is we've got our tube coming down into this plate, and we've got a moment rotating that way for the most part. And what happens is we start to form a couple. All right, so it's going to push on this side, and it's going to pull down here. The problem we have is it's right here, it's not pushing against anything, it's pushing against this plate. There's not any material on the other side of that plate to take the load. What we want to do is actually drop this plate down so that we can attach right here. Right, and it's all into this big member right here. All right, just push. Have that force go right into it. All right, we want to do the same thing down below. I'll draw this in green. All right, so that's right here. We find that we don't have a tube here, so we need to add a hole for our tube and just weld it right in there. All right, we can even have, if we don't want to drill a hole in that plate, we can have it sit right down against that surface. So very simple fix. What happens if we do nothing is we just have silly zigzags. All right, let me draw this a little bit bigger. Our force has to go this way and make that turn, and same thing here, has to make a turn. Why make it do that? Okay, our second one here is right under the cylinder. You can see the cylinder up here. We got this edge that's on the main structural beam that just gets cut off. The force and the stress still goes all the way over here. Now, being that it's a vertical plate on the side of our section, it really doesn't add too much, so it's not a real structural issue. However, it doesn't have a good transition. All right, we would ultimately want to see our plate have some form here. Maybe it looks something like this. So we're not super stiff all of a sudden. We want to max the flexibility of this I-beam with our shapes here. So we have really tapered entrances into the big section, and the same thing up here. All right, simple thing to do. If you were doing FEM, this you would catch it pretty quickly. Okay, our next one is actually kind of comical. Let me make it a little bit bigger here. You can see it's the top view of our cylinder, and we have this plate right here, and we have another plate on there that hold that cylinder down. Now, I would get rid of these. They're not needed, for the very reason of we have this, and this is the part that I find funny, this piece of all thread right here that's holding it down. Now, I would highly recommend that you use a U-bolt rather than bending all thread for two reasons. One, the all thread has a plating on it of some kind, even if it's just a white zinc. It's got it, and as soon as you bend it like that, that plating is cracked, and you're going to have red rust forming pretty quick, and you can actually see it throughout the portion. Now, it looks like somebody painted it before they put it on, so it's not such a big deal. But it is funny. I would highly recommend just spending a couple extra bucks to get a U-bolt. And maybe they couldn't find a properly sized U-bolt. No matter what, I would also recommend having something in between them, one to deal with the vibration, because you're going to have, you know, your edges of your all thread rubbing against the cylinder. That is just not a good thing. That's going to rub it in that cylinder. It's going to take the paint off, and you're going to end up with a lot of rust very quickly. All right, this one here has been painted, so it's got a little bit more protection. Probably needs to be loosened up, painted again, and reassembled. All right. Also, with these brackets that are welded on, there's no way to remove the cylinder without sliding it all the way down, which could possibly lead to gouging of the cylinder as you're taking it out. So those two welded on brackets just aren't needed. Just get a good U-bolt and put it on there. Okay, so in this last example, you can see we have our passenger side tire, we've got our axle, and right here we've got a crack. Now let's look closer at this crack right here. Okay, so our crack, you can see it starts all the way over here, comes in, and comes down, and goes all the way to the end of the material. This is just a bend right here over the axle. Now, I bet you whoever designed this thought they were doing a good thing, welding it right there, but actually they should have just bolted those two plates together. All right, for two reasons. And I would put my bolt right here. All right, just drill a hole, probably a 3/8 bolt would be more than enough. All right, so you want to join those two pieces together on the neutral axis of the axle, and that allows us to not create a stress concentration in the top surface, but allowing it to, you know, have a relief, if you will. So what happens here is axles, you will rarely, if ever, see them welded to something. And the reason is the road vibrations are just so excessive that you can't ever deal with this. This is why you still have wooden hammers or wooden handled hammers, you know, with a compression joint of some kind to a steel hammer head. All right, you would never see them welded together because that weld is going to crack because of the vibrations. All right, same thing here. Okay, so what you want to have is a joint that can slip a little bit. All right, back in the old days, they used to bolt and rivet things together, and it, you know, that they could move just a little bit with vibrations. When they started welding things together, they came up with you know, similar riveted designs would be fine. Welded ones would have cracks and stuff in here. So this is one of those things. You want to keep those vibration cycles down, and you want to have those things just move relative to each other a little bit. So the force here, you got the weight of the machine pushing down on the right and the axle holding it up on the left. So all you have your structural joint in there already. All you need to do is just fasten them together a little bit to keep the loads together. So that way if you hit a bump and the whole thing flops up, you know, your axle doesn't flop out from underneath. All right, and that's all that you need to do there is add a hole there on the neutral axis with a bolt in it. Done. Well, thank you for watching this episode of The Mentored Engineer. This actually completes the structural topics that we want to address with our log splitter. We're going to move on now to the hydraulics and the power transmission of it. So thank you for watching. Have a great day.